So in this video, I want to be talking about intercepts, symmetry, domain, and graphing them. So I've already explained how to find the intercept, symmetry, and domain and what they are. So for this equation, let's say x squared equals x positive 4. I'm not really going to go into a detailed explanation how to find those. I'm just going to do them real quickly here. So to find the x intercept, we're going to put in a 0 for the y value. So 0 squared equals x positive 4. We will solve and find that x equals negative 4. So for this, we'll have the intercepts of negative 4, 0. Now, I want to actually show you how these work on the graph. The intercepts for this equation, for the x-axis, it would be negative 4, which is right here. 0. That's where the intercept would be on an actual xy graph. So for the y-intercept, we have x squared equals 0 positive 4. Y equals x squared positive negative 2. So therefore we would have 0 positive negative 2. So these are the intercepts. For symmetry, on the x-axis, I'll put a negative y squared equals x positive 4. We can easily get the same equation. Therefore, it is indeed symmetrical to the x-axis. For the y-axis, squared equals, put in a negative x positive 4, and we get x squared equals negative x positive 4. This is not symmetrical to the y-axis, so I'll put an S for not symmetrical. How about the origin? I'll put 0, 0 for that. We're going to put negatives in both values here. So we put a negative y squared and a negative x. Replace both of them with negatives to find if it's symmetrical to the origin, positive 4. And yeah, so we get not the same again. So this is not symmetrical to the origin. And then real quickly for domain, yeah, so this is symmetry. Domain here, if we were to have the equation x squared equals x positive 4, we solve for y. That's the positive negative square root of x positive 4. And we think, well, what values can we put in here? Well, we can't get a negative value for this, right? That would be imaginary. So if we were to put in anything like a negative 4, we get a 0. That would work, but we put a negative 5. Would not work. So if we had a negative 4, you could solve for this. It could be equal to negative 4, but not below it. So x must be greater than, and then it has to be less than infinity. So it goes all the way to infinity. And that would be our domain right there. So I've already pointed out how you would put the x-intercept on the equation. I said the point was right here. For the y-intercepts, 0x, positive negative 2. Alright, so a positive 2 here, and negative 2 here. Now, by our symmetry, I can already tell what kind of graph this is, right? You can see that it's going to be symmetrical to the x-axis, and it's not going to be symmetrical to any other two. Now, the domain, you can't put anything less than it. In order to plot this equation, I can solve for y, which I've already done previously here. And if I were to put in any value, let's say a 5. So put a 5 in on the x-axis. 5 plus 4 is 9, positive negative 3, right? So if I put a 5 here, that's 2, 3, so there's 5, right? And then I go up 3, positive 3, negative 3. You can see this is going to be symmetrical to the x-axis. And I'm using one value per block, so I can draw. So that's how it would look like, right? On the graph. that's how the graph would be. So that is how to use symmetry intercepts in the domain, use them in graphing.